movement. This is the new packet, green front. We're going to go to page 5. So the first page has the vocab on it. The second page has the anticipation guide. The third page is the table of contents, which hopefully is numbered correctly. And then you're going to flip over the table of contents on the other side. That's going to be page 5. This is going to be this set of notes. If at the top you could write in Earth and Moon's movement, you don't need to write this in, just get this in. All right, we're going to flip back to the anticipation guide, and you're going to write true false for what you think on 1 and 2 on the left-hand side. So as the Earth spins on its axis, it rotates around the sun, which takes 365 days. True or false? Number 2, distance between the Earth and the sun does not change during Earth's year-long orbit because the Earth's orbit is a circle. So the distance doesn't change. True or false? All right, let's start looking at how the Earth moves. The north to the south pole. That imaginary line is called an axis. So if you've ever seen a globe, you usually see one end right there, the other end down here, north and south pole. Imagine that that's a line straight down, right? And when you start looking at the spin of the Earth is also called the rotation. The spin of the Earth, how long it takes to go in one full circle, is a day and a night, 1 day, right? 1 24-hour day. So the Earth travels around the sun. If you didn't know this, the Earth does travel around the sun. And when it does that, it has its own name or term. It is not rotation, but revolution. So the Earth goes around the sun, and it takes 365 days. However, it is not exactly like this, where it's a beautiful, beautiful circle. No, it's not. It is not a full circle. It's not a complete circle or a perfect circle. It is actually something called an ellipse. An ellipse is an elongated circle, or think of like an oval, just as like an oval. It's a flattened circle. And what it means by this, and you can see this is kind of like a flattened circle, and this is Earth's revolution around the sun. So one of the things it talked about was revolution, how I remember revolution versus rotation. So rotation's that spin, that's this right here, this spin right here. Whereas revolution, it revolves around the sun. A revolution sounds a little bit like a resolution, which you typically do in the beginning of the year for the whole year. It's supposed to be for the whole year. But think of it like that. It takes 1 full year for a resolution, kind of like a revolution. Not the ones where you go to fight wars and stuff like that. This is a revolution. It revolves around the sun. And as it's revolving around the sun, that red line, it is rotating at the same time. So we have different spaces or different places we are in front of the sun. And then we have the motion of the moon. So here's the thing. We usually see this side of the moon at all times. It's because the motion of the moon's revolution around the Earth and its rotation on its axis, that means how long it takes to spin, is the exact same time, which means a day and a year on the moon are the same length. It takes 29.5 days. So when I'm going around, say here's the sun, right where my hand is. This side is always going to face the sun. But as you can see, as it's spinning, it's facing the same way. But this just did a whole rotation, one whole spin. So 1 moon day is the same length of a moon year. How long it takes to get around the Earth. And again, it's 29.5 days, almost a month. Okay, so the distance between the Earth and the sun change throughout the year, right? Because it's an ellipse and an elongated closed curve. So the distance sometimes changes. So one of the things I asked was, when do you think we're closest to the sun? Usually people are like, hey, we're closest in the summer because it's so hot. Actually, it's the exact opposite. When it is winter, we're closest to the sun. But the thing is, we're tilted. And so the earth is usually drawn like this, but it sits tilted. You can see how it's tilted. And because of this tilt, we're not always facing directly at the sun. We're not more towards the sun. Sometimes we're away from the sun. And in the winter, we're away from the sun, like pointed away from the sun, closest to the sun. So we have less sun hitting us, as opposed to the summer where we're tilted towards the sun, even though we're farthest away, so we get the sun's rays more direct, which causes us to heat up more. All right. And if you think back to earthquakes, and we were looking at the outer core, the S waves couldn't go through the outer core because the outer core is liquid. Well, that liquid outer core helps, it moves. There's movement in there. Because there's movement in the outer core, and we're spinning, we're rotating, that causes something called the magnetic field. In the magnetic field, I don't know if you've ever seen magnets. Usually you have a red end and a blue end. Well, that's kind of like what the earth is. You have a magnetic north and a magnetic south. Now here's the thing, it's not always the same. Magnetic north isn't always our north. Sometimes it flips and it's our south. It's like the magnetic north is actually pointing south. It's weird, happens every so often. Just thought I'd let you know. But because we have that movement in the outer core and it's spinning in the outer core, and then we have this spinning, we now have a magnetic field. Well, why is it important that we have a magnetic field? Fun fact, you should probably write this down. That magnetic field is like a shield on top of having that atmosphere that helps protect us. That magnetic field protects us from solar winds, solar flares that come from the sun. And here's a good picture. Here's our magnetic field. It's not a tiny, tiny little magnetic field. It's huge. It protects us from solar winds that could harm us. All right, so quiz time. I would put movement. Quiz 1. 1, 2, 3, 4, 5. All right, let's look at 1. Right there. Earth spinning on its axis takes how long, and what do we call it? Is it 1 day is a revolution? 1 year is a revolution? 1 day is a rotation? 1 year is a revolution. So how long and what is it called when it does this? It is 1 day and 1 rotation. We are rotating, spinning on our axis. Earth takes how long to do 1 revolution? Is it 31 days, 365 days, 29.5 days, or 1 day? A revolution, again, is this big one right here. That is 365 days. The rotation is these little ones right there. All right. Earth blanks around the sun in 1 year, and its path is blank. So Earth orbits around the sun in 1 year, and its path is elliptical. Earth revolves in 1 year, and its path is circular. The Earth revolves around the sun in 1 year, and its path is elliptical, or Earth rotates around the sun in 1 year, and its path is circular. Now here's the thing. There are two answers that are great. They answer the question, but one is even better than the other. So the best one right now is C. C, we revolve around the Earth, the sun. But yes, it's also called orbiting. So if I was doing a test and these two came up, I would accept both answers, no problem. What causes the Earth's magnetic field? Is it movement of material inside the Earth's core along with the Earth's rotation? Movement of material inside Earth's core along with Earth's revolution? No one knows what causes with certainty, or there are 4 different types of theories. Well, this one, you know it's not C and D because we can figure it out. And it is movement inside the Earth's core. We just got to remember which one is making us spin. And that one's got to be rotation. So A. Revolution sounds like resolution. That's 1 year. Last but not least, how many rotations? How many rotations, spinning in a circle, does the moon have after 5 revolutions? Is it 365, 29.5, 5, or not known yet? This one's really, really, really tricky. It is 5. So if I have 5 revolutions around the Earth, it is rotated 5 times. How many Earth days would that be? So all I would do is 5 times 29.5, and I get 147.5 days. So almost, that'd be like 5 months-ish, like maybe 4.5 months. All right. So go back to the anticipation guide. We're going to write our answers on the right-hand side. As the Earth spins on its axis, as it spins, it rotates around the sun, which takes 365 days. No. As the Earth spins on its axis, it revolves, or revolution around the sun. Revolution is where it goes around the sun. And it takes 365 days. All right. Number 2. The distance between the Earth and the sun does not change during Earth's year-long orbit because the Earth's orbit is a circle. So the distance doesn't change. This one is false. It is elliptical, which means it's that, like the flattened circle, long flattened circle. All right, let's go to the summary real quick, which is back on page 5. Day and night are caused by Earth's rotation on its axis, or by Earth spinning on its axis. Rotation is when the Earth orbits the sun. Spins on its axis, and revolution is when the Earth orbits the sun. So rotation was the Earth spins on its axis, and a revolution is when the Earth orbits the sun. Describe Earth's orbit and moon's movement. Earth's orbit is elliptical, or a slightly flattened circle, and the moon faces one direction towards the Earth at all times because its rotation and revolution are the same, 29.5 days. All right. So that's the end of the notes. If you have any questions, please don't hesitate to ask, and I hope you guys have a nice day.